chunking, auxiliary elements, and commutation as a topic for Math Circle. Students come to Vika school with the goal of getting better at math, and we believe that most of the students run into difficulties with math due to insufficient problem-solving skills. Developing these skills is our main goal. Problem-solving skills are important for all professions and especially for engineering and science. We develop problem-solving skills and teach problem-solving strategies via specially designed exercises. The exercises allow us to teach one strategy at a time and visualize it. The exercises are suitable for students of all ages. Perimeter problems. When solving perimeter problems, students learn to use symmetry, divide a problem into smaller parts, and add auxiliary elements. Students also learn how to move parts around in order to simplify problems. After I will discuss perimeter problems, I will present area problems that provide opportunity to practice the very same strategies. Symmetry. When you need to find a perimeter of a rectangle, you can do it faster because rectangle is a symmetric figure. You need to measure only 2 sides instead of 4. With a rectangle as an example, we emphasize that accounting for symmetry helps us with solving problems. As a supplemental topic, the students solve a few problems that deepen their understanding of symmetry. For example, students might be asked to finish these or similar symmetrical patterns. If the first pattern is more or less simple, the second does not have mirror symmetry and is challenging for some students. Chunking. When the sides of a rectangle are too long to measure comfortably, students can break the line segments into smaller parts. This approach accelerates their work and reduces the number of mistakes. Auxiliary elements. There is no symmetry in this figure because one side has a hole. Drawing an additional line adds symmetry and simplify the solution. We tell the students that the additional line is called an auxiliary element and explain its importance in problem solving. Symmetry cannot be used in order to find perimeter of this figure. Measuring each piece takes quite a time. By shuffling around pieces of the perimeter, we can try to simplify the problem. Shuffling. We can move around pieces as long as the answer doesn't change. The pieces of this figure's perimeter can be shuffled to make a rectangle. With the rectangle, the problem becomes simple, and the perimeter can be found quickly. Perimeter problems frequently require creative thinking and are perfect for practicing problem-solving techniques and developing problem-solving skills. We provide the students with a variety of such problems. Area problems. In area problems, students find the exact areas of figures in terms of graph paper squares. They practice with the same problem-solving techniques that they had already practiced in the perimeter problems. There are, however, some difficulties with area problems. Students make mistakes when using nodes, the points where the graph paper lines intersect. In this triangle, the hypotenuse does not go over the nodes A and B, but a lot of the students believe it does, and try to use it for solving area problems. The non-zero thickness of real drawn lines create this confusion. In order to avoid such mistakes, we introduce two rules that the students need to follow when solving area problems. Rule 1. Students are allowed to use nodes along lines if the lines are vertical or horizontal. These nodes are considered to be given. Rule 2. Besides endpoints, students are not allowed to use nodes that tilted lines seems to be going through. Seems okay doesn't work. On the picture, tilted lines do cross the nodes. However, these nodes are not allowed to use. Chunking. In this problem, in order to find the area most efficiently, students need to break down the figure into several rectangles. Then, finding the area is straightforward. Symmetry and auxiliary elements. The students are asked to find the area of the rectangle are not familiar with any formulas. They only know how to find an area of a rectangle. So usually they start from subdividing triangle into small rectangles. As soon as they start, they are reminded that what seems okay cannot be used and that they need to find exact area. Usually at this point, I propose them to add lines to make a rectangle. Now, using the symmetry of a rectangle, the students can find an area. Finding the area of this figure requires creative thinking. The figure can be subdivided into a rectangle and 3 triangles. Then the calculation is straightforward. At that point, the students already understand what shuffling means. When the students recognize that a protrusion has the same shape as a concavity, they can easily solve the problem. After rearranging the part, the calculation is simple. It is important that the students who already applied shuffling in perimeter problem can independently apply the approach here. In math, shuffling called a commutative property. Auxiliary elements. The area of this triangle cannot be found using symmetry or chunking. However, adding auxiliary elements helps. With additional line, a rectangle with area 27 is built. A problem can be solved by subtracting from 27 the areas of 3 right triangles. Combining techniques. Using a formula for finding area and combining several problem-solving strategies, the students can solve these fun problems. Generally, students enjoy the problems and when discussing their solution, gradually develop understanding of problem-solving strategies. As you can see, in spite of the rules, a forbidden knot was used in the second problem. Here, I wanted to list again the 4 strategies that we foster using perimeter and area problems. The strategies are based on chunking, shuffling, pattern recognition, and using auxiliary elements. The strategies can be used in all spheres of life, and especially in engineering and science. Benefits of the topic. Students improve their knowledge of geometry, but also develop problem-solving skills and vocabulary. They learn to recognize common strategies in very different problems and consciously apply them. As far as I am aware, in literature, a comprehensive analysis of problem-solving strategies does not exist. Therefore, I would highly recommend such a unit to be covered in teacher training. It will help the future teachers to recognize and start teaching problem-solving techniques.